Today's theme is SmartPLS. Great afternoon to all of you. How can we be smart when we conduct research, especially when we do our data analysis? What is SmartPLS? How can it help us? Okay, let's invite our smart panelists to discuss the beauty of this software. They are Professor G.D. Samarasinghe and Dr. Isuru Koswatha. Professor G.D. Samarasinghe is currently serving as a professor in the Department of Industrial Management, Faculty of Business, University of Moratuwa. He served as the head of the Department of Management of Technology, University of Moratuwa from 2015 to 2020. Then he was graduated from the University of Sri Jayawardhanapura, Sri Lanka, securing a BSc Marketing Management Special Degree with a First Class Honours Division. He obtained both MBA and PhD in Marketing from University of Colombo, Sri Lanka. He has published over 4 research papers in both internationally and locally reputed journals on marketing and management, and presented conference papers at more than 20 international and local research symposia. He has been a postgraduate, MBA, MPhil, DBA, and PhD research supervisor, as well as visiting academic for several local and foreign universities. He is specialized in analyzing quantitative survey data. His teaching and research interests include marketing, consumer behavior, entrepreneurial marketing, and digital marketing. He has served as a member of the Educational Reform Committee of Sri Lanka Stock Marketing since 2017 to 2020. He has been serving as a member of Board of Study of SLIM since 2023. Dr. Isuru Koswatha is an assistant professor in business and management at the University of the West of Scotland. He is also an external examiner at the University of Dundee and adjunct senior research fellow of NSBM Green University. He is part of the Social Impact Leadership and Management Group at the University of the West of Scotland and specialized in organizational resilience, entrepreneurial leadership, and business sustainability. He also co-chairs the Staff Research Forum of UWS. He was recently awarded and is a recipient of the prestigious UWS Vice Chancellor Studentship 2023 for his project on the topic of the role of leadership in building resilience towards sustainable economic growth, Scottish SME perspective. He completed his PhD from the University of Manchester in 2020 and skilled in mixed method research, structure equation modeling, and necessary conditional analysis. So, dear panelists, the research lounge is yours. Why is SmartPLS important for our research? What kind of software is it, Professor?
Thank you, Dr. Nayani Gunawardena. First, I should be thankful to Dr. Nayani as well as our FGS Dean, Sir, Professor Aditya Alvis, for the opportunity. And also, I should be thankful to my colleague, Dr. Isuru, as well, for the valuable participation. Then, my topic course, you might see, it's talk about something called latent variable modeling, which is something very practical in social research as well as in some other engineering also. You see applied research. Sometimes, though you are having engineering PhD or research, sometimes you measure some attitudes, some scales-based measures are there. Therefore, this SmartPLS provides some sort of exploratory and something we call unobservable construct you can measure. I can share my PowerPoint, then you can see why it is important and some other important unique factors of this SmartPLS. Now we call this is not the SmartPLS. First, I would say partial least square analysis. Right? I'm not promoting any software. The company and the brand is SmartPLS, but there are so many other SmartPLS brands, PLS brands. But first, I would say why partial least squares. We say in short PLS. It talks about the variance-based analysis. If you look at so many SEM techniques, first I should mention what is SEM. In research, we say structural equation modeling. That's a very practical tool for the social researchers and applied researchers to look at the relationships between variables. Sometimes you are having independent variables, dependent variables, mediator variables, moderator variables, control variables. Sometimes in research, you want to measure them. Sometimes in the Viva, you have to show that you measured this thing and you have to talk about the validity and reliability. Therefore, these are some of the concerns and challenges we have in this, what you call psychometric properties. There's a term called psychometric properties. You are measuring something which is intangible, not tangible. Like I might say leadership or the customer's attitude towards robotics, acceptance in supermarkets. These are some of the challenges we have. Therefore, I can show you some research also here, like for you to get an idea. Maybe you are into information system, engineering, management, marketing, or different multidisciplinary projects are there. I will show you one example like this. You can see one research paper we have done this year. Here you can see this model, right? You can see here, I'm looking at the impact of human-robot personality. Now we talk about this robotics, AI and the things, but here look at the social perception, attitudes of the people. In that context, you can't directly measure these attitudes. We call psychometric properties. Unobservable realities are there. Therefore, we say variables are measured using indicators. Indicators are becoming the variables which are largely intangible. We call unobservable. Therefore, you can see in this model, I think, have I shared this one? All right, you can see that one, right? Functional intelligence, sincerity, these are some of the psychological things. Not visible. Now, can you see my screen? Yes. Okay. Yes. This is something you can see, right? These are some of the attitudes-based measures, simply if I say that, right? I'm looking at whether customers' acceptance of this, what you call retail service robots, how it's happening. It's a psychological process of attitudes and the behavior of the people. Therefore, these sort of construct we can measure through survey or secondary data or your supermarket data. You have different measures, secondary data or primary data. Therefore, these sort of things are becoming very complex in the analysis. Why? You can't observe these things. Therefore, this PLS type software, not only PLS, SEM, I say that. If you look at the SEM generation, there are different generations. One is covariance-based SEM. They use a covariance matrix to assess the model, test the particular conceptual framework. We call in business, these are mind models. You are having something in your mind, independent, dependent, mediator, moderator variables like this. Then if you have a model like this, you should be able to find an SEM. That's a trend. Otherwise, you can use normal SPSS like software, Excel. But now, if you want to have a good publication or a good journal, they ask for SEM. That's the importance for research students to have this sort of a software. Under SEM also, you can see there is another one, Amos. That is one brand. They use the covariance matrix. But here, PLS, they use variance matrix. Therefore, there is a particular argument. Some people say that Amos-based what do you call covariance-based method are better than like PLS. Therefore, there is argument. But my argument is these are complementary. If you want to create a new model, new theory, improve existing theory, the new variable, like look at here, we bring something like consumers perceived control as a variable which intervene, mediate the relationship independent dependent. In such scenarios, we are trying to improve the theory with a new variable. That's why we say exploratory, predictive nature, something novel in the context. Therefore, we want to have a SEM, and also PLS is especially for the what you call predictive and new model development. Model development and testing both are happening simultaneously. That's the beauty of this SmartPLS or PLS software, right? Therefore, in my PowerPoint, you can see now the important thing, this sort of model ultimately you have. When you go to this software, you see it's a we call path models. In SEM language, this is a path model. You see inner model and outer model. I will explain what is inner model. You can see here circles are there in the middle. There is a relationship arrows between these circles. We call that's the inner model. That means you are having large independent, dependent, mediator, moderator variables. We call inner model. But look at there's outer model as well. In the outer model, you see there are indicators, which can be the certain things you get from the questionnaire, interviews, you measure on a scale, for example. Or in the finance research, sometimes you get maybe investors, maybe value, sometimes financial ratios from the secondary data and annual reports. These are the observable properties we call outer model. Therefore, outer model properties create variables in the inner model. Therefore, we say that in this language, there is outer model, or we call the measurement model. Inner model we call structural model. Therefore, to assess this one more comprehensively, we use SmartPLS or other SEM software. That's importance. Therefore, sometimes in your research, there can be a part where you have to look at the relationship. You have to talk about the assessment of validity and the reliability. We say that. Sometimes you do a survey, but survey sometimes not reliable. Therefore, you have to look at the validity and the reliability. Sometimes you know jargon, Cronbach, alpha, composite reliability. These are the terms. Therefore, easily you can do this from a power user perspective. Otherwise, if you use Excel or SPSS, you have to generate the tables. But today, the modern researchers, a new generation, they don't like these sort of tables. They like sort of visualization like this. Therefore, simply you can draw the model, dragging these boxes and arrows and linking them, and you can simply run the model. I will show you. I think Dr. Isuru is there, but let me few minutes to show how to get this software. That is also very, very important, right? If you look at this one, you can go to this website, smartpls.com. You can see the website. And there are frequently asked questions. So I'm going to that one. Then for a researcher, another important thing can be like this: is there a student version, and how can I use this one? Sometimes you have to pay and buy this one for the long term. But as a student, first you can try what you call this student version. I think you can see here. Is there a still free student version? Yes. If you go there, all the things are there. It's a lifetime student version. But there are some restrictions. Only 100 cases you can use sample size. Likewise, there are restrictions. But the problem for you to learn as students, you can use this one first. But otherwise, if you need to run for your final research, 1 month free trial professional full version you can get. That is also there, right? You can see here. Under frequently asked questions, how can I apply for 30 days free trial version of SmartPLS? For that, you need a valid internet license ID, internet email ID, and also your computer. Then you can run that for 30 days trial version. That is something about the software availability. Then I will show you. I have this on my desktop. When you install this SmartPLS, you see this icon, right? SmartPLS 4. That's the latest version. And if I talk about even PhD publication in social research and applied research in management and business, after 2010, SmartPLS is getting very popular compared to other covariance-based method. This is a variance matrix-based method. This is getting very popular because you want to develop new models, test new theories in a different context, introducing new variables. Therefore, this is much flexible and very easy. Therefore, these are the strength of this software. Then you can see the particular platform. When I log into this one, you can see the platform. That's the fourth version, SmartPLS 4. This is much advanced and user-friendly. There are so many things combined when you do in SPSS and other software. Therefore, you can see my projects here. What I have done, you can save the projects. Then if I show you something like, you can see this sort of models I can do, then you get a particular empty canvas when you have a new project. First, I will show you. Let's say new project. Yes, you have to give a name. Let's say, sorry. Create. In this platform, then you have the project open. Then you see import data file, create model. First, you need the import data file. I will show you some data files. You see here, data files like this may be in Excel sheet or SPSS or CSV formats. You might have large amount of data, right? Maybe secondary data, or it can be primary data. You get from maybe different sources. Then you have to enter them right in the normal way. Then you see the data. Here you see my samples. I have about here, I think 95 participants I have interviewed. Therefore, these are some of the things you see when you start with the package. And when answering to your question further, sometimes in practice, there are some problems. You can't do some analysis because of these issues. One thing is small sample size. Sometimes we talk about in statistics, these problems. I will show you. Another important thing is the yes, you are having a small sample size. Sometimes when you go for very reliable studies, traditionally you need big samples. Otherwise, you can't generalize the findings. Therefore, that's a problem for the modern researchers. Sometimes you are having a small sample, but you want to make some inferences. In that case, no way. Therefore, SmartPLS provide some avenue for you to use and analyze small sample data. Even with 50, even less than 50 also you can use. But if you look at some professors like Professor Haya and Ringel, minimum 50 might be at least may be used to make a reliable analysis. You can bootstrap. Therefore, using a small sample, you can generate subsamples, 5,000, 10,000 like, right? Resampling technique is there, I will show you later. Therefore, that is one situation. The other thing is, in normal research data analysis, you need normal distribution. We call parametric assumptions. That's the other problem, distributional assumptions. You need a normal bell-shaped curve. Sometimes in reality, you don't find this bell-shaped curve. But in that case also, SmartPLS or PLS software usually provide you the foundation. That's a non-parametric bootstrapping technique. Therefore, they create a distribution from your small data set, which is non-parametric. Though parametric or though non-parametric, you can use this one. That's the beauty of SmartPLS, right? That is one situation. Even the secondary data you can use. The new models you can use. Therefore, this is the flexibility and the innovativeness of the software. That's why we recommend in such situations to use this PLS software than other methods. But I'm not criticizing other methods, which is complementary to develop a new theory, predict, and explore novel ways in the theory development and testing. I think that's my point. I think Dr. Isuru is there. If you can add something, Dr. Isuru.
Dr. Isuru?
Yes, Professor Dinesh.
Yeah. In the SmartPLS, research studies.
Certainly. Thank you, Dr. Nani, again for the opportunity, and thank you, Professor Dinesh, and everyone who's joining us. Yes, as Professor Dinesh mentioned, I think SmartPLS, or PLS rather, has been in the spotlight in the past couple of years, and especially SmartPLS. Why it has become so important is, as you rightfully mentioned, Professor Haya, Ringel, and most of the, let's say, business researchers who are coming from Europe are strongly pushing this as a platform. And that's where I think if you look at a lot of the publications, very high level publications that we see in the ABS rankings, it has seen a serious increase in publications that are pushing SmartPLS as a software. And again, why it has become important is the visualization aspect, and also the boundaries it is giving us to push theory, because in most traditional settings of quantitative analysis, whether it is using SPSS or regression, there is we would say comparatively a lesser chance of you to advance theory, and there is more base for you to theory test. But with SmartPLS coming into the equation, with the visualization aspect of and coming with some of the traditional downsides and overcoming some of those traditional downsides of SPSS, I think you are able to really push boundaries with theory testing. And also in terms of the availability of software, as said, you can use, I think, the 30-day subscription, but unfortunately beyond that, I think they have this system where you're not able to use the same computer. So maybe if you are really serious about using SmartPLS, once you have got that practice of using, let's say, 100 points of data, I think you can purchase a 1-month subscription as a university student. So all you need to do is, I think you have to put your university address and purchase it. I'm not sure entirely how it works. I know some universities in Sri Lanka, they offer this as part of their research council or something, which is free of charge for the researchers. So 1-month subscription, I think it costs around 20 euros. So I think that's something you can do. And also the other thing I would also want to say is that it is because research has become quite multidisciplinary, it really helps you to visualize data in a very organized way. Because when one of the things that I have seen is that when you're trying to develop new projects with researchers from different fields of study, it becomes very difficult for you to really talk about very technical aspects without having that visualization aspect coming into the equation. So that's where, again, SmartPLS can be a tool which brings in different researchers from different fields in a very easier way, rather than trying to convince or try to go with the traditional approach of looking at theory and having to have a technical understanding of certain theory bases to start off with. So I think Professor Dinesh has basically touched on all bases what I wanted to say. And yeah, looking forward to seeing new developments, especially encouraging new researchers to jump on the platform and start playing around with it. And to start things off, as much as you are attending these sessions, there is a lot of resources available. If you go on to YouTube, I think Ringle has its own starting guideline for new researchers. So all that information is there for you to really start working on this. So yes.
Okay, thank you, Dr. Suru. Professor, so then in this discussion, you mentioned we can use any type of data, primary or secondary, or the file, SPSS or Excel. Then what data type should we have if we want to apply SmartPLS? Quantitative or qualitative?
Yes, yes, Dr. Nayan. Yes, a very good point. Sometimes in social research, we deal with not always what you call, we say that these are, sometimes we say, you look at different level of scales, no? You see ratio data, that's the highest level of property, right? You look at the actual natural values, but sometimes in social research and in some applied research, you can't measure everything from the natural, right? What you call ratio variables, right? You say person's height, weight, something that's the natural value, which is a natural zero, we say ratio. You can deal with ratio values as well in SmartPLS, but not on ratio values. Even less than that, you can deal with what you call interval scales, right? Interval scales. You measure the attitudes and with the equal intervals, right? Sometimes Likert type scale questions are there, right? 7 point, 5 point, then that's the interval level. Even less properties, still you can make it. Sometimes we say not the metric data, right? Sometimes even less than that, ordinal data you can deal with, right? You arrange the data, but data in a particular order, right? First, second, third, sometimes. There are such scenarios in making decisions sometimes. Therefore, we say ordinal data. If you know statistics, you know interval data, ordinal data. Then lowest level, you see even nominal data, right? Even nominal also possible, but not pure qualitative text, but anything which you can order or which you can arrange, like nominal, sometimes categorical data we can use. I will show you here, then you can understand, right? I will import a particular data file here. I might say, I take this one, 95 cases. Then you see here, I am importing a particular data set from a survey, or it can be one secondary data, which is in the form of metric. It can be interval or ratio, even ordinal, right? Sometimes maybe I measure loyalty of a person to a brand, which is metric. Sometimes you say interval or ratio together, they say metric. Even some data you can see here like this. I look at different type of companies. Some companies are manufacturing, some companies are service oriented, some are NGOs, likewise different type of data, right? We call categorical data. Even categorical also possible, right? You see categorical, even you can import into your data sheet. Further, you can see binary even, no? Like yes, no, two categories are there, binary variables, and also ordinal. Therefore, that's the beauty. You can have different levels of measurement in your data sheet and see their connections. That is another important aspect. And the other thing is, the only problem is if you look at a dependent variable, which should not be categorical. For you to look at the standard deviation and the variance, you need the dependent variables at least to be ordinal, minimum level ordinal, not the categorical. But other variables, independent variables, moderator, mediator, other side, which can be either categorical, ordinal, or metric, or binary. That's the beauty. Therefore, sometimes in some software, there are constraints. But here it's relaxed to a certain extent. That is one thing, and I want to show you another thing. Now I import this data set. Then I think we had no time to elaborate. This is about 12-hour session, 1 day or 2 day workshop if you are learning SmartPLS package. But I will just show you. But we will have a hands-on maybe in December UOM research week. I will arrange a 3-hour introduction session hands-on. Then any participant who wants to learn further, they can come. I think Dr. Naini and FGS will communicate that one. In the UOM research week, we will have session. Now I have imported this data set. You can see here, right? Now before you do the analysis, you can see the nature of data, whether there are missing values. You can see simple descriptives, mean, median, scale mean, minimum, maximum, observed value, observed minimum, observed maximum, standard deviation, courtesies, skewness. You can see whether your data is parametric, non-parametric, bell-shaped, normal distribution curve is there or not. These things are there, like at a glance you can see. Then this side you see your questions or the data labels, right? Data labels. I have data labels here. Then that's the initial data set. Then you can see correlations, raw data you can see. This is the initial thing. Now I have imported data, right? Now I'm having matrix data and different type of data. Now I go back. Then I have imported data. Now this is my project. Today I open Dinesh 1. This is the data set. It can be SPSS or Excel, CSV file, even any file you can import here. Now that's another improvement in the latest version. Then there is icon called create model here. Then click on that. Then you have to again give a name, right? You have to choose PLS-SEM we use here, partial least square SEM I'm talking about. But don't forget, now PLS is equipped with more than this PLS traditional one. Using normal regression also you can run here, right? Now maybe you are using SPSS software regression, but that is through the table. But here you can draw the particular model and run it. Therefore you don't have to be a statistician. You have to be as an applied researcher manager. You should be able to interpret the beta coefficient, R square, likewise experimental power. You have to interpret with the p-value. You can test the hypothesis, right? That's very simple there, right? You can simply save the what do you call this graphics and everything. You can simply save. I will show you. Then PLS-SEM I will give you Dinesh 1 save. Now you see this empty blank canvas is coming. Now where you have to draw the model. It's very simple. Now you see here, select icon is there. Latent variable icon is there. Connector is there. There are so many. Quadratic effect is there. First I go to select. Now look at left side, you see your data set. Now I have imported. I have measured loyalty using several indicators, price, satisfaction, leadership, governance. Likewise, my indicators are here, right? My sample size is 95 in this case, but my indicators are this. What you measure as a primary data or secondary data. Now I go to latent variable. Click that. Then click on your empty canvas. Then there is a box coming. You have to simply type the name of the variable. I might say quality. Enter. Then you see this circle is coming. This is your variable. This is your variable. But now this is not active. When this is active, this is becoming what do you call this blue color. Then I am measuring quality using here. You can see several indicators. Quality 1, quality 2, quality 3, quality 4. There are 4 indicators. You can select and drag it. Then it's connected. But I'm having 3. If you want, you can select the first one, hold the shift key and select all these 3 and drag it. Now you link your data, right, indicators to the variable. Likewise, you can draw the model. Now I will select another one. I have another variable, loyalty. Then again, if you want to deselect, you have to escape. Deselect. You can again select. Go to again latent variable and click. Then my other variable, for example, let's say loyalty. And very simple. Now I am having 4 indicators to measure loyalty. Loyalty is a psychological construct. That's why I say these are latent variable. In our theme also we talk about latent variable based approach. In some research you are having intangible, unobservable properties like this. Quality you can't measure in one indicator. Loyalty of a person or employee you can't measure in one indicator. Therefore you need multiple indicators. Therefore I select all these and drag it. Then you see, right? Again you can save, go to select. Then you can arrange them as you want. You can arrange them. Then it's very simple. Again, I take another variable. I take satisfaction. I drag it. Only single indicator. Enter. Then you see. This is another important thing is if you look at some other SEM software, you need multiple indicators. Like even AMOS, like as far as I know, they need at least 3 indicators to measure one latent variable construct. But in this case, even using one indicator, you can measure unobservable latent variable. That is another strength of this software, right? Single indicator. Sometimes in finance like field, you measure certain things using single indicators, secondary data, like some financial ratios, profitability like values, single indicator. Therefore, that is also accommodated here. These are some of the strength of the software. Now I can connect them. There's a connector here, right? These are very basic skills you should know. Select and try to link. Very simple, right? Then again, connector I have here. Now you can arrange. Now this is the independent, this is a dependent. If you're having a model like this, I will show you. Maybe based on literature review and maybe sometimes using your exploratory research, you develop a model like we call mind model like this. Now look at this. You have a model like this. Now this is your mind model. Now you want to test this with the indicators and the data. That's why I draw this model on my canvas. It's very simple. Now again I go to connector. Quality affecting satisfaction. Satisfaction affecting loyalty. Now this is a mediator variable in our jargon, right? Sometimes in statistics people talk about, but here visually you can see that's the beauty. Quality leads to satisfaction, satisfaction leads to loyalty, quality directly affects loyalty. Therefore, this is the indirect relationship, we say that, mediate, right? Mediate. And sometimes price can be a moderate. I will show you that how to do that also, right? Latent variable, I might say price. Price, I have 2 indicators here. Then I connect it as a particular moderator. I go to connect. It's a moderator. You see, this is a moderator relationship. You can easily do this. Very, very easily and flexible. That is, now you draw the model. This is a mind model. Therefore, then second step is to run the model. You see here, calculate button is there. Very simple. You see here, PLS-SEM algorithm is there. And the bootstrapping is there. And also consistent algorithm is there. Bootstrapping is, if you want to mimic covariance-based method, usually we go for consistent algorithm and the bootstrapping. But if you want to first time test a new model and develop something new, we advise for you to go to normal regular algorithm. Therefore, I go to PLS regular algorithm and I run it. You can go with the factor focus, path focus, or principal component analysis focus. I go to, let's say, factor focus. Type of results, standardized, unstandardized, mean centered. Usually we go for standardized base. Even if you want, you can give the weights. Even individual variables, you can give the weights if you're having some assumptions, right, in your model. Otherwise, normally you can go for the default, right? Start calculation. That is generating the results. Now you see on your left-hand side, reports are there. But on the model also, the values are coming. Right? If you are running normal SPSS, you have to look at the tables and draw the model. Now you can directly copy-paste this. You can import into your thesis chapters, right, to your Word document, right? That is one thing. And don't forget, this is the algorithm. But again, I go back. I want to look at the significance. Therefore, I go to bootstrapping as well. Minimum 5,000. According to Ringel and here, they say that at least you have to generate using these 95 cases, sample size 5,000. Bootstrapping. It's a subsampling technique, sampling generation technique. And further, you see certain tests like whether you are having directional hypothesis, then you can go for one tail. But if you have direct non-directional hypothesis, no positive or negative impact, simply the relationship you can go for two tail like aspects. Then I go for bias corrected and accelerated bootstrapping. Since I have no guarantee about my data sets normality. Therefore, I prefer to select bias corrected one, right? Since my data is not normal, therefore we recommend in such cases bias corrected and accelerated bootstrapping technique, right? And the pick seeds, but if you want, you can have random seeds as well. But for the moment, I will select this. Now my subsampling process is happening, and they create a distribution and they give you the p-value, probability value, t-value, significance level, right? Then you can get something like this. Then again, you can go to reports. The other thing is reports, right? You can get all the reports, like look at the what do you say, path coefficients. These are the beta values. Normally you look at in normal regression, you would see the beta value, independent variables impact on dependent variable. Then we call path values, path coefficients here, right? You see those values. Then you see their t values. T value 1.96 and above, p value is less than 0.05. Then you can reject the null and accept the alternative. Likewise, you can do this, right? I'm not going to elaborate, but now you can see. Now you have the flavor, then you yourself can master this, right? That is another thing I want to highlight. You can go to the graph again. If you want, you can show the p-values in a model. P-values and path correction. Then within bracket, significance level is coming. This is the inner model. Now I mentioned there are two types of models. This is the outer model. Now you can even change the direction of this. Align left. If you want, you can hide them in the final model. Hide indicators. Likewise, you can do a lot of things here, right? As you want. That's the flexibility. If you want, you can delete one indicator to improve the reliability and the validity. Likewise, you can show these things, right? Show indicators. Now look at here, you see these path values, but before that, you have to look at the assessment of validity and reliability, measurement model. There you see, I'll show you. Again, I go to normal bootstrapping, so not bootstrapping algorithm. Then you see the reports coming. Here, look at what we call construct reliability and validity. Then you get count by alpha, right? We say that 0.7 and above much better. What do you call the construct reliability is there. Then composite reliability. These are some of the indicators about the validity and reliability of your model. These are the reliability. Then what do you call average variance extracted. This is the validity of the construct, convergence validity. This should be 0.5 and above. But now you see here certain values are low. Then again you have to go back to the model. You can go to the graph. Perhaps some poor loadings are there. Look at this should be factor loading. We say that 0.7 should be minimum, but sometimes less than 0.7, 0.5 and 0.4. These are having poor factor reliability, what you call indicator reliability. If you delete these things and run the model, you can improve the original validity and reliability. That's the flexibility. It's a few second thing you have to do that, right? Within few seconds, you can do the flexibility and improve the model, right? That is another thing I want to highlight. Then that's a very basic way how you develop the model. And reports you can even import. You can save the reports. That is another thing. Dr. Isuru also can add something, I think.
Yeah, I think that's something I will also mention. So when I was also doing during my PhD studies, I think coming back to the question of using quantitative and qualitative data, obviously I had a mixed method study in my PhD. So initially when we did the qualitative segment on interviews, because my study was mainly looking at resilience and different factors that contribute to resilience in Sri Lanka in the garment setting. So we had interviews, and then obviously once that was there, we then at a second stage, we identified certain dimensions, which were then, as Professor Dinesh mentioned, we were able to use it in a PLS-SEM setting. And the beauty was, again, when you have a lot of different factors that are coming through, more likely than not, if those factors are not really established in literature as such, because you are still in this journey of an exploratory kind of a study, you might encounter a situation where some of those loadings are not strong enough. And that doesn't mean it's a discouragement. It's just that, again, the software gives you room for, again, deleting certain factors and then multiple times running the model to see what kind of changes and improvements are there. So I think that's where PLS-SEM really helps. But again, I think in the second part of today's session, we will further encourage you to again develop PLS with what we call NCA, because again, it gives us some more insights that might be not possible in certain situations with PLS. So I think, sir, that's something I think we can naturally build on as the conversation goes on.
Yes, thank you, Dr. Isuru. I think I want to share another thing, like maybe sometimes we talk about now with the theory development, something like this. Hope you can see my screen, okay. Sometimes for the advanced researchers in applied research and social sciences, in quantitative methodology, you see sometimes some concepts you can measure formatively. Some concepts, some constructs, some variables, latent variables, you can measure reflective. Usually we see a lot of things are reflective. If you look at like covariance-based methods, normally they look at the maximizing the covariance matrix, and they are looking at more into reflective-based measures. Now, example here you see left side, anxiety, person level of anxiety, how anxious is anxiety. You can measure that using 4 indicators. Maybe it's a psychometric property, right? Attitudes and some feelings, perceptions. How much is sweating, sweating. Then how much is worried. Then sleep disturbances is having, and also irritability. If a person is anxious, is suffering from this particular disorder, anxiety, he is showing these characteristics. Now look at first happening is anxiety. Now look at arrows are going towards from the circle towards the squares, indicators, measures, direct measures, observable things. Therefore, anxiety is happening first. The results are the indicators. We call that a reflective measures, right? First, anxiety is happening. After that, only resultant things are becoming the measures, right? But look at the other side. There are some models. Now here SES stands for social economic status of a person, right? Social economic status, let's say, person social economic status, right? Status in the economy, a person's. You can measure that using 3 things. One is income that person has. The other thing is the occupational status he has, right? His job and the right position. Third one is education level, right? Whereby you can measure person's socio-psychological status of a person. Now look at the arrows, other way around. No? Now you see from the indicators, arrows are headed towards the larger, unseen, unobservable, what you call latent variable, which is we call socioeconomic status of a person. Now, first thing is indicators are happening. After that only, as a consequence, the larger construct is happening. We call this a formative. Therefore, in real life, sometimes you are measuring certain construct for the concepts formative. Some are reflective. But SmartPLS and PLS software allows you to use both in the same model. But in traditional SEM methods, covariance-based method, the only thing is reflective measures are there. But sometimes if you are developing a new model, new tools to measure something, psychometric properties, it can be one formative you can develop, right? Using like this. Then I will show you how to do that in PLS, right? Then now here, when you draw the model, by default, it's coming reflective, right? That's the nature. Line left. Now quality I am measuring as a reflective one, right? First quality is happening when the quality is there, others are happening after that as a result of quality. Quality is the cause, indicators are the effects, cause and effect. But sometimes in reality, you can see this sort of relationship. You can go to this one. You can right click. Then you can see. I want to remove this calculation, right? Okay. Then select. First I left align, right click, invert measurement model. Now this is reflective, no? But if you're having literature, and some maybe expert interviews, you understand this is not reflective, this is formative, then invert. Now you see, right? Sometimes it can be there. Therefore, this is now formatively assessed. But loyalty is assessed reflective. Therefore, PLS allows you to have both in your model. That is another strength of the model, right? That is another thing you can say. Then in such cases, again, you can run the model having the two different type of measurement properties, right? This is formative, this is reflective, this is also reflective, right? That's the concept I want to highlight, right? Reflective and formative distinction. Then another important thing, when you are looking at any SEM, including PLS, you have to report the findings of your analysis using the two-step process. This is a tradition on any SEM, whether you are using covariance-based method or variance-based. First, you have to report the measurement model. As I mentioned earlier, reliability, validity, discriminant validity, likewise, you have to look at these things. Then you have to look at, after that, improving the model, reliability and validity, that's the outer model. Inner model you have to assess. We call inner model means the structural model, that where you look at the testing the hypothesis and the predictive relevance of the model, R-square of the model, effect size. These are the inner things. Ultimately, you talk about your main findings based on this structure of the model, right? That is another thing I want to highlight. Then I will show you that also how to get these things. Again, you can run the model. PLS algorithm. Then you see these things. You see R square is inside the circle. You see R square value, right? That's the explanatory power. And there is another thing. Yes, for the independent variable, you see even sometimes we use R square adjusted, right? If you want to compare that several models, we use R square adjusted. Likewise, you can get different things. Then again, I go to this one and I run the bootstrapping for the significance. Then you can go to results also, as I mentioned earlier. And another thing I want to highlight is this. My next slide, you can see. Now, this is one article. I can even share this article with you. They talk about Ringel and their team, including Professor Hare, when to use and how to report the results. This might be sometimes useful when you use this software and report the analysis, right, in your thesis, right? This one you can find on the ResearchGate also. I will share this one. And the other thing is this one. Some possible applications, right? Even Dr. Isru also would share certain aspects, especially NCA. Another thing I want to highlight in this order, higher order composite model. What is a higher order model? I will show you something like this. Now here you see quality, what I showed you, right, in the model. This is a very simple model, right? We call this a first order model. Why? Directly you see the independent variable dependent on the median. But look at next example, next graph. Compare this. Now quality is here. But look at this model. I have a variable called reputation, which is form of several dimensions. In the real world, when you measure certain larger variables, they are having sub-variables. We call dimensions. Therefore, dimensions are forming a larger construct. Example here. This is a higher order model. Why I am saying higher order model? Your independent variable here, for example, reputation, is form of several other variables. We call this a higher order model. That means your target construct, target variable is formed by several sub-dimensions, sub-variables. Therefore, here reputation is a higher order or second order construct, right? Even in PLS, you can do that also. Right? I will show you a different model, then you can understand. Yes, can do this. I might say reputation. Now we call this is a repeated indicator approach. Now you can try to create higher order construct. Sometimes this can be novel to you. Some people second order construct. Therefore, sometimes in the postgraduate level, you look at high order construct as well. It might be used. Now like this, you can draw something like this here, and you can run the model, right? The repeated indicator approach. So therefore, again, all these indicators you have to drag on to the larger construct as well. Then only this is becoming active. Now look at here. I have several different quality. You can hide this. Now this is developing high order models. You can get that knowledge. Also, perhaps you might have sometimes not directly measurable one larger construct, right? It is set up, right, sub-construct, right, that forming the larger construct. We call it high order construct. Therefore, these sort of flexibilities are there. Within few hours, you can run your model and get the results. That is one thing. Then I want to show you another important thing. My PowerPoint you see. This is I want to highlight. We call multi-group moderation with micro. I will just explain what is multi-group moderation. Like now in this, let's say, now I have in my data set, you see, I think Dr. Naini asked about whether which sort of data you can work with. Sometimes you can deal with binary categorical variables. You can compare the groups. Now in this case, I have last question, last indicator, type of the firm. I collected this data about particular firms. Some firms are service-oriented organization, some are manufacturing organization. Now I want to look at this model, dividing the data set into two groups. Whether service-oriented companies are performing better than the manufacturing organization in terms of this model performance. In that case, we call something called multi-group analysis. First, I will go back. You can go to normal algorithm. I have created groups already. Therefore, you can see under data here, grouping option is also there. I run the normal model plus group data set as well. I have two groups I have, right? One group is service oriented, others are manufacturing oriented. Start calculation. Now you see the results. But look at, now this is the overall model. But here in this icon, you can see group one. Now they take only maybe 45 firms, let's say, service organization. This is their model. Then again, I can go to group 2. Then you see path coefficients difference, right? Then again, I can go to original model. That's a full data set. We call this a multi-group moderation. Therefore, you can do a group-wise comparison. That is another very important thing. Group we call multi-group analysis, right? And even path you can highlight, use relative values. Then you can see strong paths are getting right bold, right? Highlighted, right? That is also there. Therefore, visually it is more appealing. That is another thing we call multi-group analysis. And further, if you go to multi-group analysis, some advanced topics are there, like you see here. Bootstrap multi-group analysis. and permutation multigroup analysis. These are some of the advanced ones with the MyCom. I'm not going to discuss these things, but if we're having a 3-hour hands-on session in the future, we will discuss those things, right? For the multigroup also, there's a concept called measurement invariance, right? To compare two groups, you want to say that means are equal between groups, variances are equal. Then only you can compare. Otherwise, it's not reasonable. Therefore, we do this sort of analysis very simple manner in this software. I think Dr. Isuru, anything you can add about this one? I talk about some possible applications.
Yeah, I think this is again another benefit of having a SmartPLS for, like, when we were doing our PhD time. Again, I had an issue where I had a matrix that we developed from literature, and we had 4 scenarios where we wanted to obviously test it out with PLS-SEM, but unfortunately that time we didn't have multi-group built into PLS, so we had to individually draw the models and again do a bit of a manual kind of a comparison. But again, that is not there anymore with PLS4 coming into the equation. So as Sir said, there is more advanced options now available for all of us to engage in it. So more for theory building and testing, especially in a multi-group setting, I think it will be quite useful if you are able to again access multi-group analysis and again develop your knowledge to start off with. So yes, I think that's an experience I didn't still have, but I'm hoping to again work with a multi-group set and see how it works out in a PLS4 setting.
Yes, I think next thing is the predictive elements. I will simply elaborate that one also. Sometimes we talk about this one. You can see here in my model, I want to look at, we call PLS predict, the new feature, right? The cross-validated performance assessment ability test, predictive ability test. We say that cross-validated predictive ability test, PLS predict. Now, sometimes this is very famous as out of sample, what do you call, predictions. Now, your sample size is 95, but you want to make a inference in the population whether this data set, this sample data set can give you a particular assurance about the what do you call, generalizing and predicting the large unknown data set in the population, right? About that one, we call out of sample predictions. We call PLS predict. It's very simple, and there are certain, I will just show you. Now they are trying to create some polls. Now I have 95 cases. They divide the data set into 10 polls, 10 subsections. Then one sample out of this, let's say 95, you divide into 10. Let's say 999 something, right? And last one 10, let's say. Then one subset they hold out as a holdout sample. And other nine subsamples they use and do something called like blindfolding technique. From that, you are trying to assess that what you call holdout samples values. I don't know whether students understand that. That's very interesting. Then you divide the data set into 10 groups. For example, here 10 polls. One data set out of that you hold as a holdout sample. From other data set, you are trying to predict that holdout one, whereby you look at how much your data set is succeeding to reach that one, right? Out of several times permutations. Then you get something called Q square value, right? That is something novel. Now we are very much familiar with R square. R square is the explanatory power of the particular model, no? How much variances accounted by independent variables, ne? Independent variables power to explain the dependent variables variance. But this is something about what you call, now you can see here. Here you see something called Q square, not R square, right? Q square predict. This should be above above 0. That means this should be a plus value. If you're having at least 0.1 to 0.3, you can say that you are having some sort of a some acceptable level of predictive ability. 0.3 to 0.5, you can say moderate level of predictive ability. Out of sample predictions, whether your data set is qualified for out of sample predictions, Q square value. First, they look at some errors. root mean standard, root mean square error, then mean absolute error. These are also coming, right? In detail, hands-on, we can discuss these things as well, how to make a decision. Simply we call Q square predict, right? Q square, right? PLS predict. Sometimes in some publications, they ask, reviewers ask, what about your Q square value? You have to report them when you talk about your what do you call model assessment. That's the importance of this predictive validity, predictive relevance. We say that. Then we call predictive relevance. Then there's another thing called confirmatory threat analysis. I'm not going to discuss that one, but that is very simple concept. You see here the model. In this model, think that as Dr. Isru mentioned, we have no evidence about whether you are measuring something formatively or reflectively. It's something novel first time. Now from the literature, perhaps you know that quality you can measure reflectively. Literature says that. But there are certain situations when you develop new models, you don't know formative or reflective. In that case, you can go to, we call this confirmatory threat analysis, where they gives you some support to decide whether your model particular variables are formative or reflective. That guides you. Normally, threat means groups of 4. Threat means. Then at least you need 4 indicators for a construct to do this analysis. If you're having less than 3, you can't do that. Right? That's a constraint. As a new model building process, you want to know this confirmatory threat analysis as well. That is the other thing I want to highlight is special features. Right? Then another interesting thing, assessing non-linearity. Right? This is very simple. Sometimes we assume linear relationships. No, perhaps we don't know whether sometimes between variables the relationship is non-linear. Right? Sometimes you see parabolas, no, like different relationship. You see that not always linear in the real world. Now I run the model. Now you see here quadratic effect. Recently they introduced quadratic effect. When you click this one, you see, right, this is highlighted, quadratic effect. Now you can click on this. Very simple. Simply you have to click. Now I have assumed linear relationships. But in reality, I don't know these relationships are linear or non-linear. Then better if you can report that also perhaps. Then I created this effect. Now I run the model in the usual way. That one and I will run the model. You see. And again, I go back and I run bootstrapping also. You have to run both, then only you can get the p-values and both path coefficients together in the model, right? That's a practice. First algorithm, then go back and run the bootstrapping. Then ultimately you can see both together, right? Both analysis you have to. Now you can see here. Now you can see quadratic effect. Now here, look at this one, relationship between quality and loyalty. You see the path value, the quadratic effect, you see it's nearly 0, right? There is no significant non-linear relationship between quality and loyalty relationship. That is, p-value is above 0.05. Then this one also same, not significant, right? But look at this one. There is a positive non-linear effect relationship between satisfaction and loyalty path, which is significant. P-value is less than 0.05. Therefore, you see satisfaction and loyalty not always linear, right? It is having a non-linear relationship. That is something you can have an idea, right? If you look at a lot of normal software, you are having linear relationships. Otherwise, you have to transform the data. But without transforming data, you can get some idea about whether your paths are linear or non-linear. Linear or non-linear. That is there. That relationship. Otherwise, I will highlight that also somewhere here. Now, there's another type of PLS. If your data is really your original data set, you find very much non-linear, there's a WAP PLS or WAP PLS. That is another one. WAP means simply non-linear. The term itself means that's a different type of PLS. If you're having sort of a non-linear data set, you can go for even WAP PLS, right? But here we use SmartPLS, and we see even quadratic effect that assess a non-linear. Dr. Naini, I think we have come to certain level, no? I think then.
Actually, my question is then, so there are so many benefits of this software. So then, but when we start our research, then how can we decide this? Because then, can we use SmartPLS in our research? How can we use SEM to our research? And how can we make that decision actually? What factors do you think we should consider in making that decision?
Yes, very good question. I think as a novel researchers sometimes ask that problem. Yes. Some supervisors say that always go to this one, but that is not the rationale I see. Now we talk about a variance-based approach, but I mentioned the other one, covariance-based approach. If you look at these sort of models, one thing is your sample size. If you are having small samples, sometimes it's very difficult for you to have these covariance-based methods. Therefore, with a small sample and if you're having non-linear relationships, and sometimes not non-linear, I was talking about non-parametric. That means you don't have the normal distribution, right? In that case, you can recommend to use PLS software. But in other cases, sometimes if you're having a large sample, let's say about 250, you are having a normal data set and very established model you have at the moment in the theory, then you want to test that here. In that case, you can go for covariance-based method like AMOS. But in other cases, sometimes very challenging situations, we find new model you develop. No literature that much about that model, no new questionnaires, measures developed. Therefore, it's challenging. In that case, we need exploratory predictive models like this, software like this. That is one situation. When if you want to again improve the model, like rather than using the existing model testing, you bring some new variables, some additions. We call theory improvements and testing. In that case, again, I would recommend PLS software. Therefore, which is complementary. To develop the model, test the initial model, you can go with PLS. But later, to test the model and you call confirmatory factor analysis process, you can go for SEM based method like AMOS. Therefore, this is complementary. But some people argue that this one is better than this. But as researchers, we should understand these are complementary. That is another important. Therefore, sample size, distribution assumptions, and the context, then lack of literature. These things is the guiding principles for to decide which software you are going to use. And then Dr. Isuru, any additions? I think you have good experience with your PhD.
Yes, Professor Dinesh, I think that's one thing you should know. I think to start off with, as a researcher, I think from what Professor Dinesh mentioned, you might understand that this is a bit of a higher level. I mean, if you look at the software per se, I don't think it's that complicated. It's very straightforward. It's very simple. However, the application component where you really apply it comes in a situation where you are really stepping into the shoes where the literature is not as established, or the sort of models are not as established. So naturally, you would assume this would be a situation where you are a student who is looking for a research-oriented program, or who is in a postgraduate level, technically, who is looking to explore a certain concept. And I think that's where you need to be really sure about what kind of question, what kind of research problem that you're investigating, rather than focusing too much at the initial stages on the method per se. I have seen situations when you are using, when you're working with different supervisors, or when you're working with different institutions, there is a tendency where certain supervisors or certain senior academics would like you to use a certain method, which is completely fine. However, you need to be very sure, go back to the drawing board, see what you're trying to investigate in your study, and see how it really complements your study. So as Professor Dinesh mentioned, in a situation where you're really trying to push your theoretical understandings, when the establishment is not as significant when the base is not as established. I think that's where PLS would be really useful, and especially other methods that we are trying to complement PLS, which such as NCA, would really come into the spotlight. So I think be very clear from the beginning and then look at the methodology is something I would suggest from my experience as well.
Okay, thank you. Professor, shall we give an opportunity to our researchers to
Yes, we have a lot of things to be discussed, but I think we gave the initial awareness only. We have further things, I think, in the hands-on session, we will discuss like even prediction-oriented segmentation. Sometimes the concept is statistically we call unobserved heterogeneity. You don't see the variances, sometimes that is not visible, but we call this is unobserved heterogeneity, right? Sometimes for the data set, you can see whether you can identify different segments, right? Cluster analysis again simply coming here. When you see SPSS cluster analysis, sometimes very difficult to understand, right? Very complicated. But here simply you can see whether segments are emerging. Then for the new researchers, this is much useful. Even for the practitioners to see, to make some decision-oriented software. And another thing is import performance mapping also, right? I think we have the time constraint, no? Therefore, I think in a later session we can discuss these things and necessary condition analysis also. I think Dr. Isnu also wanted to talk about. Taking few minutes. Shall we?
Yes, I can talk about in a few minutes. Yes. So I don't know if you can see the slide. So basically what I'll try to be as quick as possible. So again, from the understanding that we had from PLS, what necessary condition analysis, which is again, I think one of the recent developments in the past couple of years, it has come to the spotlight where we are now trying to understand what are these kind of necessary conditions in a data set. Now, forget all this. If I was to just simplify it now, if you look at the first example, a student will not be admitted. Now, if we take as an example, this is a student will not be admitted to a PhD program. Let's say, for example, if their MSc dissertation score is low. Okay, so if you're having a low, if you're done not really well in your MSc dissertation, the possibility of you getting admitted to a PhD might be not there. Creativity will not exist without intelligence, or AIDS will not develop without HIV. So what are we trying to say? So we are trying to say that these are some of the sort of conditions, or these can be certain bottlenecks that are in place, and if those bottlenecks are not addressed, it's guaranteed failure. Again, looking at the same example, if you don't do well in your MSc dissertation, it's guaranteed that you will not secure a place in a PhD program. Okay, but the interesting thing here is that just because you do extremely well in your MSc dissertation, that doesn't really guarantee that your PhD is going to be a success. So that's where this necessary, or the sort of necessary sufficiency logic comes into play. And that's where we are trying to introduce the idea of necessary condition analysis, where traditionally in a PLS-SEM setting, when you have, let's say, for example, already established theory. Now, we again, with Professor Dinesh, we were looking at a very simple example. We were looking at, again, transformation leadership, and we took the 4 dimensions. And again, if you apply this in a PLS-SEM setting, we can see that all the 4 dimensions are significant. So from a PLS setting, we can say that that is where the limit is, because all the 4 are already established from theory. There is no really new insights that you can provide to this theory base. However, when we apply the necessary condition analysis, which is this necessary sufficiency logic, we can really identify how these different factors contribute at different levels. Because if you look at it at the 100% level, which we usually look at it from a PLS level, that is where we can see, okay, at 100% level, all these 4 factors are contributing at a very high level, 90% to 80%. However, during the process, let's say at 50% capacity or 50% engagement of employees, how these different factors have contributed is something that you can build insights on. And that's where I think the theory building process, from a theoretical point of view, from a very qualitative perspective, you can really embed it into PLS. So again, I think going back to Dr. Nayani's question at the very beginning of how PLS can be used with different data sets, as much as it can be used with quantitative data, when you combine PLS with NCA, you can really bring in the qualitative segment for theory building and theory writing. Now, for example, we found out in this particular study that we are still investigating, intellectual stimulation was contributing to employee engagement at the very beginning level. And then when it got to the level of 70 to 100%, it slowly diminished. So again, what that really means is that it opens up a new avenue for us to really start thinking of the already established theory and start improving that with the NCE understanding. So that's a very basic flavor of what we can really do with it. But because of time constraints, I think I will not go into too much detail. Again, I think in a future session, Professor Dinesh, probably we might be able to have a bit of a hands-on approach and really start exploring a few more models and help with the sort of theory writing concept with NCE and PLS combined.
Yes, thank you. Give me 1 minute, 1 or 2 minutes to talk about even this NCA, as Dr. Isuru explained. Sometimes we traditionally use qualitative methods like qualitative comparative analysis. That's a qualitative technique. But now nicely that has been taken into the software and they say that it's a necessary condition analysis. Traditionally we used that using qualitative techniques, manually, qualitative. But now that is statistically possible using your data set, using necessary condition analysis. Sometimes they say fuzzy logic, or there are different terms they use that, but now in a simple way you can do that. Now even if I share this screen, you can see how it's coming, right? But you can see here, you can study. Normally here there's a regression part. The regression you can do this. When you go to regression, you can draw the regression here, calculate necessary condition analysis. You can write. Then you see bottleneck tables, and there are certain values are coming. We interpret the bottlenecks and the significance. You can see a bottlenecks. Like in Dr. Isuru gave an example. Now normally when you test the hypothesis in normal any SEM or SPSS, you look at the end results, rejected or accepted. But some hypotheses are rejected, but it still needed those variables to activate the initial relationship. That's the beauty of this NCE. Now you judge that when the hypothesis is rejected, that fact is not important. End results, but here you can see first 10%, 20% how this relationship is activated. Now look at here. I'm looking at this quality one, leadership one. Likewise, variables are there. Then I look at at the 70%. Sorry, yes, at the 10% of this quality, no variable is activated. But when you come to 30%, you see leadership 2, leadership 3 is getting activated. Perhaps leadership 2 and 3 might be rejected as the ultimate hypothesis level. But here you need even rejected ones to start the things. That's why he said, Dr. Isuru said that some conditions are necessary, but not sufficient. Some are necessary as well as sufficient. Some are not necessary but sufficient. Likewise, different variables are there. Therefore, that provides you a particular way to understand in depth traditional hypothesis testing that for the theory building. That is something I wanted to highlight. Thank you.
Thank you, sir. Okay, dear students, please bring your data to our research week that will be held in the first week of December. So we'll arrange a hands-on session for you. Then our professor will be there. You can get expert advice for your research in person. So we are going to conclude the session. As we promised at the last research launch, today too we discuss another vital aspect of data using SmartPLS. Stay with us in future as well. We wish to bring another fruitful discussion to you on the topic of data analysis in the upcoming research launch in September. In conclusion, all our sincere gratitude goes to panelists for their priceless contribution made on our behalf in today's session. Goodbye.